Please go ahead, ma'am.
Good afternoon, students. In today's class, we are going to discuss about an important concept of local area network, that is spanning tree protocol. So most of the time, even when we are doing packet tracer experiment, we would have done a topology in like this. So even in a local area network administrator connects the switches with redundant link. So redundant link in the sense, suppose here is switch S1, S2 and S3. So S1 has a path, or S3 has a path to S1 through trunk 3, or it can travel through trunk 2 and 1. So now what can be the, this is actually implemented in every local area network in order to have a primary path as well as secondary path. So whenever a primary path fails, the secondary path come into picture. So, but what can be the possible problem whenever we connect a network like this? Let us see this video. So I would like to play this video. So you could see that S2 updates the MAC address table and it forwards to all the ports except the port that it has received. So that is the characteristics of a switch. So S2 now forwards the broadcast packet, it broadcasts out to all the other ports. And now every other switch again, it broadcasts the packet. So S3 and S1, now it broadcasts it out except the port that it has received. So now it has received it. You could check this packet. All right, so it has now gone from S2 to S1, and from S1 it has come to S3. And now again we could see that in this topology it is coming again to S2, which is a looping structure. Okay, now if you could see this, what will happen is again S2 will forward this packet to the port except what it has received. So now it is again broadcasting the packet. So this is a serious case in a local area network, which is called as the layer 2 loop. All right. So now we have to block one port so that there is no more looping inside a network. So that function is done by means of a protocol called spanning tree protocol. So I would like to show you one more very worst case that can happen whenever a broadcast packet is sent in the network. So here I would like to show an example, right? So let me just play this. This is called as broadcast storm. All right. So whenever a broadcast packet is sent, you could see how it is forwarded. So at one point of time, whenever a switch receives a packet, it is going to get overloaded. All right. So we could see that it has created a storm like architecture or storm like problem in the network. Yes, at one point of time, the traffic is overloaded and it is clogged. Okay, so the entire network is clogged. So whenever there is a loop like connection inside a network, we have to block one particular link. Okay, so that the network traffic is moves smoothly inside a network. So that is done by means of an algorithm in a local area network called spanning tree algorithm. So any local area network, wherever switch are involved, we will have a spanning tree algorithm. So this is what we are going to discuss in today's class about a spanning tree protocol. So what should a spanning tree protocol do is, again, let me show here. So a spanning tree protocol should block one particular link. All right. So suppose there are two paths available, it should block one particular path. And whenever there is a failure of this link, it should open this path. Only whenever there is a failure, it should open this path. Okay. So the STP should do two things. One is it should block all the redundant path. Okay. There is extra path that is available. Point number two is whenever the primary path fails, it should open the secondary path. So these are the two things that it has to do. So how it is done inside a network, in a local area network, how this is done is what we are going to see in today's class. So these are the steps that is taking place whenever a spanning tree protocol is done. The number one is it elects the root bridge. Okay, from the set of switches that you have in the local area network, it elects the root bridge. Then it elects the root port from the root bridge, every port of the switch is designated or given a name, and one particular port is blocked. Okay, so we will see in detail how is this done. So how is the root bridge elected is what we will discuss in the next here. The root bridge is elected by means of three things. One is once again. Yes. So the root bridge is elected by means of the bridge priority. Okay, you have a bridge priority. So by default, it is 32768, and you can even set a bridge priority. All right. So if your bridge priority is less, then more priority is given for that particular bridge. Or here they call a switch alternatively by a name called bridge. Then you have the extended system ID, all right, and then your MAC address. So these are the different parameters used to elect a root bridge. So how is this root bridge elected? We'll see here. So say here, for example, there are three switches S1. It is having a priority or bridge ID 24577 and MAC address of this. And here S2 is having a priority 32769. Again, here it is having 32769. So you could see here that switch S2 and S3 are having the same priority. So initially, a bridge PDU, okay, so a bridge protocol data unit, okay, which contains the bridge ID and the MAC address, is exchanged between all the switches. Okay, so let me just. Yes. So now you see that there is a switch S1. So S1 forwarded packet to S2 and S3. All right. Similarly, S3 also exchanges. Now, when S3 receives this particular information, okay, this information, it just compare it data with it. Now it finds that 24577 is the less priority. So it elects, it says that, okay, my root bridge is S1. Okay, it just decides that its root bridge is S1. Now again, S1 receives BPDU from S3. Now it finds that its root priority is less. Its priority is less. So it decides, okay, the root for this network is S1. Now coming to S2. Okay, so coming to S2, it receives from S1 and S3. Suppose you imagine, first it receives from S3. Okay, it receives from S3. Now it has both the priority is same. Both the switch has the same priority. Now what happens is the tie. Okay, so it's a tie, and the tie is solved by means of the MAC address. Now you see that S2 has a lesser MAC address than that of S3. So now it will select that, okay, the root for this network is S2. As of now, S2 will decide the root for this network is S2. Now, after receiving the packet from S1, now it compares its priority with that of the priority of S1. So now it decides, oh, that is having a lesser priority. So my root is S1. So by exchanging the bridge protocol data unit, they just understand that which one will be the root bridge. That is the first step of the spanning tree algorithm. Okay, the spanning tree algorithm designate a single switch as a root bridge. That is the first point. So how do they decide who is the root bridge? By means of the bridge ID. Okay, or if the bridge ID is the same, then they decide that based on the MAC address. Okay, whichever is lesser will get a more priority. Now imagine that what are the other parameters used is, as I told you, the bridge ID and the MAC address. Then next, I should designate the ports. Okay, so I should elect the ports for whichever is the blocked port, whichever is the open port. So there are different roles for every port in the network. Okay, so for example, let's say this is a root bridge. Okay. So all the ports connected to the root bridge are designated ports. Okay. That is open ports. So this is called as D. This is called as D. And this is also called as D. Okay. Designated port. All right. So now I should select the root port. So this S1 is solved. The port roles of the S1 is defined. So by default, whichever ports connected to a root bridge or designated port, that is solved. Now I should solve the port roles for S2. Okay, so I should solve the port roles for S2. Now, how do I solve the port roles for S2 is, I should compute the path cost of S2 to reach S1. Okay, so how do I do that? I'll just come here. Okay, so the path cost is selected in this way. If it is a 10 Gbps link, the path cost is 2. If it is 1, it is 4. 100 Mbps 19, 10 Mbps is 100. So these are the default path cost used for STP. Okay. Now what happens here is the path cost is summed up for that particular link and then it is calculated. So now I just calculate the path cost for this. It is having a single link. Okay, so this is having a single link. So the path cost is 19. Okay, so path 1 cost is 19. Here I should take 2. So the path cost is 38. So this is the root bridge because this is the shortest path for S2 to reach S1. So this is given a name R. Similarly, for S3, this is selected as the shortest path to reach the root bridge. So this is given a name R. All right. So now the port roles of this particular port for S2 and S3 is defined. Now you may get a next question. What if the path costs are same? Okay. So what if the path costs are same? In this case, if you see here, so for S2, all right, so you say S2, this is one path available, that is trunk 4 and trunk 1. So the S2 can reach the root bridge by means of two paths, that is 1, 4 and 2, 3. These are the two paths available. Now in this case, the path cost is equal. Okay, so the path cost is equal. So how do I solve it? How can I solve it? All right. Then the next one called the bridge ID come into picture. Okay, so the bridge ID come into picture. Now I select here. This is S4. Okay, I just see this side. Okay, I just see this side. S4 is having the bridge ID of 32769 But if I see this side, it is having all fives. So the bridge ID is lesser in this case. Okay, the bridge ID is lesser in this case. So I elect this as my root port. Okay, so the equal cost path tie-up is solved by means of something called the bridge ID. Okay, so bridge ID is nothing but it is the combination of your bridge priority plus the MAC address, or priority appended with the MAC address is your bridge ID. So it is solved by means of this. All right, so now I have elected the path cost for all the ports. Okay, so now this by default, these are designated ports, these are root ports. Okay, now coming to this path. Okay, this path, which one will be the designated port and which one will be the alternate port? Okay, so which one will be the designated and which one will be the alternate port? Now again, the bridge IDs are compared. Okay, so the bridge ID of this and this is compared. So I'll show you wherever bridge ID is shown. Yes. Now here you see here, by default, these three are root ports. This is also selected as root port. Okay. Sorry, this is designated port. These three are designated port. These two are selected as root port. Now the question is, which one will be the alternate port or the blocked port and which one will be the designated port? Now again, you compare the bridge ID of two switches. The bridge ID of S2 is less. Okay. So now this is going to be the designated port and this is going to be the alternate port which is blocked as of now. Okay, suppose if this happens every time whenever a topology of this kind is connected, I'll show you in this packet tracer. So now if you see the packet tracer, I have taken three switches. So now if I just connect the three switches in a triangular fashion, so the flow port labels are shown. So the link lights is also shown. You could see that initially the switches are getting booted. Now, yes. Now, if you could see that this particular fast Ethernet port is in orange color or in the amber color, which means that in this loop-like structure, this is the blocked port. Okay, this one is the blocked port. Okay, so right. Again, if you one more thing is, suppose if you feel that this MAC address is also, you imagine that this MAC address is also 00A00, that can never happen. Okay, if in that case, if the MAC address is also same, in that case, the port number is taken. Okay, FA0/1, FA0/2, that the lesser port number will take the highest priority. So this is how the spanning tree protocol elects the root bridge, and it also elects the ports role for a switch. Okay, so one will be the blocked and other one will be the open, and this takes place. Okay, this is what I was explaining about. And now, so how is the spanning tree protocol done? Is by exchanging the BPDUs, right? So how often the BPDUs are exchanged? You have certain timers to regulate the exchange of the BPDUs. Number one is the hello timer. Okay. The hello timer is by default for 2 seconds. For every 2 seconds, it says a hello to make sure that the other switches are live. Okay. And then you have the forward delay timer. Okay. So the forward delay timer is nothing but this is a timer which this is the time in which the switch takes for listen and learn. Okay. And by default it is 15 seconds. And then the maximum age timer. The maximum age timer is the time the switch takes to decide which the port roles, the root bridge, and everything. Okay, by default it is 20 seconds. Now we saw that the operation of STP, we saw the STP timers. Now we will move into STP modes. Okay, so we have certain states with which every ports operate. So initially the port will be in the blocking stage. So you could see whenever you connect a switch and put a link, initially it will be in the amber, it will be in the orange color. So what is actually happening when the switch is in the orange color? So it is in the blocking stage. Okay, for 20 seconds it will be in the blocking stage, and then it moves to the listening stage. Okay, so this blocking stage can be for the first time when you connect a link, or whenever a link comes up. Okay, whenever links comes up, it will be in the blocking stage. And next it is in the listening stage. It is the stage where your BPDUs are exchanged. Okay, your BPDUs are exchanged. Now, in the blocking, listening, and learning stage, no data will be transferred. Okay, there is no data transfer. Only the BPDUs are transferred. And in the learning stage, the election of root bridge, the port roles defining, every process takes place during the learning stage. And then when the switches are switches move to the forwarding stage, it is where the data transfer takes place. So we could see here the blocking stage, the BPDUs are received and no update. Okay, the MAC table is not update and the data frame cannot be forwarded. Similarly, in the listening stage and learning stage, you can receive and send. Okay, every switch can receive as well as the send. The listening stage, again, no update is done and no data transfer is done. In the learning stage, the updation of the routing table or the MAC table is done, and again, no data transfer. But in the forwarding stage, again, alone the data frames are transferred. Okay, the forwarding stage alone, the data frame are transferred. So this in this chapter we saw about STP operation, STP timers, and STP port states. Okay, there are different versions of STP available. Okay, so for every single VLAN, we can have an STP. Okay, so per VLAN spanning tree is possible for every single VLAN. Similarly, you can also have something called PBSTP, that is called per VLAN spanning tree. Okay, so these are all Cisco enhancements, Cisco proprietary protocols. Okay, so then you can even have PBSTP plus. So PBSTP plus will have special features like port fast, BPDU guard, and all those things. We will discuss what it is in the coming slide. Then something called rapid STP is there. Okay, so rapid STP is where you will have the faster convergence than STP, because for certain ports, some states is skipped. Okay, so instead of moving from listening, learning, forwarding, it just moves from the listening to the forwarding stage. Okay, so that is called rapid STP. So in order to enhance the speed of convergence, only if the port roles are defined, the data transfer can take place, because only when the data transfer take place in a loop-free environment, you will not have a bandwidth wastage. Okay, so otherwise the packet will be keep on circulating in the local area network. It will be eating unnecessary bandwidths, right? So in that case, we have come out with an evolution of STP. You can read your notes. Okay, so for further thing. And now I would like to talk about the port fast and BPDU guard. All right, port fast and BPDU guard. All right, so when a device is connected to a switch port, all right, so when suppose you are connecting a computer to the switch port, so initially what happens, a 15 seconds of forward delay will be there, and then again each time it has to wait and 30 seconds, because you have connected a device to the switch port. All right, so immediately what happened, that particular port undergoes the forwarding stage, the blocking stage. Initially it is in the blocking stage, then it will come to a listening stage, then it will comes to the learning stage, then only it will go to the forwarding stage. So what happens is, until the forwarding, listening stage and the learning stage is done, it has to wait. The device has to wait for a DHCP initiation. So we know whenever there is a dynamic routing protocol used, sorry, dynamic host configuration protocol used, the host requests the DHCP server for an IP address. But now, once you connect a device, it has to wait for 15 seconds to initiate this process. So what you can do is you can configure that particular port with port fast capability. Okay. So what is port for fast capability? So initially how it is done, blocking, listening, yes, learning, and then forwarding. So these all process is not required for any port that is connected to a device. So these all steps are required for any port that is connected from a switch to the switch, because only we have to block the secondary paths from switch to switch. So for any ports that is connected, for example, you imagine this is a switch and this is connected to a computer here. All right. So this port need not undergo all these port states, because this is connected to a computer. Okay. So obviously any packet that comes here will go here, and any packets that is originated in a device will come here. There is no chance that there is going to be a loop here. But this device unnecessarily wait for 15 seconds to initiate the DHCP process. Now, when you enable a port fast in this particular port, okay, it will not undergo these two stages. From blocking directly, it will go to forwarding. So the packet comes here to the switch and it can take part in the network transmission. Okay, so this is called port fast. Okay, this capability is called port fast. Okay, so now a port fast enabled switch port should never receive a BPDU, because see this, there is no need of this particular port to receive a BPDU, because that particular port is not going to be involved in the STP calculation. Okay, in that case again you can involve that particular port to a process called BPDU guard. Okay, you can say I'm protecting you from BPDU guard, so that any BPDU does not come inside your vicinity. Okay, so you can avoid, okay, unnecessary transmission of BPDU packets beyond this particular location. So these are the different features available in STP, or these are the different enhancements done for an STP, and the STP is renamed as rapid STP so that the convergence is so fast. And then because of that, your LAN is ready, the local area network is ready for any data transmission. Okay, so this is about the spanning tree protocol, and I would like to talk about the next protocol called the Etherchannel. So this is the chapter 5 of your module 2. Okay, and I would like to talk about the next topic called the Etherchannel. Okay, so Etherchannel is one more feature available in your local area network. So it is called link aggregation. Okay, you can group the ports. Okay, you can group certain port and the full bandwidth, and that port is considered to be a single port. For example, let me just say here, and I just take a small switch. So I say 2960 switch. I just take two 2960 switch, and so what I do is I just connect. So I have connected three wires connected to switch 3 and switch 5. Okay, so this is switch 3 and switch 5. Now what I can do is, this is link 1, 2, and 3. So I can aggregate these 3 links together to form a single link. Okay, I can aggregate these 3 links together to form a single link. All right. So this is one feature available in the Cisco devices. Okay, Cisco devices supports this particular feature. Now what I can do is the first 1 and 2 I can have as VLAN 10. The third one I can have it as VLAN 20. Okay, so now the full bandwidth of all these 3 channels, I can have it to be a single link. Okay, so that is a feature of Etherchannel. That particular Etherchannel protocol supports that. Okay, so then how it is done? So you see here, logically, physically it is not actually possible, but logically you have 1, 2, 3, 4, 5, 6 ports. Together you logically say that you group those ports to be a single port. Okay, so spanning tree protocol will visualize that particular port as a single port. All right, so spanning tree protocol will see that particular all these 6 channels to be a single channel. So here in this Etherchannel, there are 2 protocols that operates. There are 2 types of protocols for Etherchannel. Protocol number 1 is port aggregation protocol. Okay, and the next one is link aggregation control protocol. All right. So, and by default, in every switch, the PAGP is enabled. Okay, and if you want, you can even enable LACP. All right. So now, how actually they operate is that PAGP has 3 modes. One is the on mode. So on mode is this particular is a normal operation, a normal switch operation. Okay, so on mode means it is a normal switch operation without any link aggregation. And PAGP desirable is that this mode places an interface in an active negotiating state. Okay, in which that is initiating. Okay, that particular port initiates a link aggregation with the other side of the switch. Okay, so imagine this is a 2 switches connected. So I say this is desirable. It means that this is sending communication to the other port to initiate the PAGP process. Okay, PAGP auto is nothing but it is it also responds. Okay, it not only send. Okay, it also respond to it. Okay, so for example, if I say this is auto, it responds to any negotiation message that it receives. And very important caution note that we have to take here is both side of a switch should be on the same mode. Okay, that is one important caution note that we have to take whenever we do an Etherchannel. And the next one is called, yes, here it is. So on and on, the channel is established. So on and desirable, no, it is not established. Desirable and desirable also it is established, and desirable and auto, yes, because one can send, the other can receive and respond. Okay, so that is yes. And auto and desirable is also yes, but auto and auto, no. Okay, so auto and auto is only both of them can respond, but they cannot send. Okay, so in that case, auto and auto, no, channel is not established. So whenever a channel is established, on and on, desirable, desirable, desirable and auto, auto and desirable. So maybe sometimes whenever your network is reported with it's not functioning. Okay, if a network is having some errors, then you have to check the mode of Etherchannel. If the mode is same, okay, in that case you will say that it will channel is established. Sometimes it will be no. So in your packet tracer for module 2, okay, in your packet tracer exam for module 2, you will get one case where two switches are connected using ether channel. They are aggregated, but you feel that this particular port will be in auto, this particular port will be in auto. Okay, both the thing will be in auto, and they say the communication is not established. Then you have to change both the modes to desirable. Okay, so in, or one will be on without any configuration, any ether channel configuration. The other one will be desirable or in auto. So in that case also the channel is not established. Okay, so you should be very careful. Sometimes this particular switch will be configured for PAGP and this particular switch will be configured for LACP. Okay, in that case also you should consider, you should check the modes. You should know how to check the mode of both the switches and then configure it. This is one case you will get when you are working with a packet tracer. Okay, when you are working with a packet tracer, so I encourage you to work this chapters packet tracer, okay, especially the configuration and troubleshooting. You follow the instructions and you work it, so that when you work for your final packet tracer exam, it will not be a tougher one for you. Again, LACP operation, this is on. LACP is active and passive. Okay, so active is the port. Okay, so the LACP places a port in the active negotiating. This port initiates the negotiation, and passive is in the state the port respond, okay, but not does not initiate, but it respond to it. Okay, so again here in this case you will have on and on, yes, on and active passive, no, active active, yes, active passive, passive active, yes, and passive is no, like auto no, right? In the previous case, similarly here passive is also no. Now we will see using a packet tracer example how to configure ether channel, how to aggregate the ether channel, and also we'll see how can you put up the virtual LAN into it. Hope your teachers would have taught you virtual LAN in the lab. So we will see how to do it. All right, and then how to configure the ether channel, how to check the status of the ether channel, how to check whether both the switches are having the same ether channel, and all those stuffs we'll see. For that, I would like to select the numbered switch. Okay, so let me take 3 switches. Switch 8, and I would like to connect yes. So both the switches. So if I hover the mouse over it, so physically I have connected only 2 links, but here you could see that there are very huge amount of links. So in this switch itself, I have fast Ethernet 0/1 till fast Ethernet 0/24. This is a very ideal switch, which this is a switch that even we have in our Cisco lab. So this is an ideal switch which was simulated. Okay, so that it has 24 ports in it. Now I would like to configure the middle switch. Let me take the middle switch, go to the CLI. Okay, so here en config t. So I set the host name to be middle underscore switch. All right, and then I say I just configure 2 VLANs, VLAN 10, name student. Then I say VLAN 20, name faculty. So I have 2 virtual LAN. I've created 2 virtual LAN. And then I say interface range. So I'm going to group it, right? I'm grouping it. Interface range of. So here you see that this switch is connected to 1, 2, 3, 4. These 4 ports, okay? And these 4 ports are going to carry multiple VLAN traffic. So I say interface range of FA 0/1 to 4. All right. And I say switch port mode trunk. Okay, those ports I have just put it up as trunk ports. All right. And then I say that exit interface range FA 0/1 to 2. Among that 1 to 2, okay, I'm grouping it as I'm grouping. Okay, so 1 to 2 I'm grouping, and I say that channel hyphen group 1. The mode is desirable. Yes, I set the mode as desirable. So once immediately I set a mode to desirable, you could see the other end of this switch is also down. Okay, or it has gone to a confusion amber state because the mode was not equal. The mode of this switch and this switch was not equal. So it has gone to the amber state. And now I say that interface range, okay, FA 0/3 to 4. All right. Then I'm grouping this channel as channel underscore group 2 mode desirable. By default, every switch will be on the PAGP. They will be working on PAGP. So again, this mode I'm setting it as desirable. Yes. So it is desirable, and I say an end, and I save the topology. Okay. So now I'm going to show some, do a show commands, show ether channel, right? It is just showing that there are two groups existing, group 1, okay, and the group state is L2 layer 2. The ports which are under group 1 is 2 ports, okay, and the port channels is only one port channel created, and the protocol working is PAGP, okay. Similarly, here again it says there is one more group called group 2. The ports are 2, okay, maximum ports allowed is 8, okay, you can group up to 8 ports here, and the protocol is PAGP. All right. So I just say, let us go here, and so I just ask to give a summary of this ports. Okay. So when I say a summary, it is telling, all right. So number of channel group is 2. Aggregators also is 2. Under every group, two ports are grouped. Okay. And it is telling port channel 1. All right. And it is operating PAGP. And initially it is in a standalone mode. Okay. I mode, standalone mode. All right. And then the second channel, okay, so it is 2 ports are under that, 3 and 4. It is again in the standalone mode. Okay, because the other side has not been configured suitably. It is, says that it is in the standalone mode. So now we have completed the ether channel configuration, this switch. Let us come to this switch, and I say config T, and again we have to give a VLAN here. Okay, so I set a host name switch underscore left. All right. And then I just say VLAN 10, name student, VLAN 20, name faculty. So 2 VLANs are created. I just give an int. Then I am telling that interface range fast Ethernet. Okay. And I say that 0/5 to 8. Okay. So I just say interface 5 to 8. So this is switch port mode access, then switch port mode, switch port access VLAN 10. So 5 to 8, I just allocate to VLAN 10. Similarly, interface range FA 0/9 to 12. All right. Then I say switch port mode access, then switch port access VLAN 20. Right. So I just say that let it belong to VLAN 20. And then This is going to carry multiple traffic. Okay, this is going to carry multiple traffic. In that case, I'm telling that interface range FA 0/1 to 2, then switch port mode trunk. All right. And I just allocate this to the channel group 1, because earlier, if you remember, I just put these two ports to channel group 1. So this side also I'm going to configure it as one more desirable, right? So let it negotiate among themselves. I just put an end and WR. Okay. Right. Coming on to this switch. So here in this switch, let us again examine some show commands. So I say that show Etherchannel, the group 1. Okay, the ports are 2, okay, PAGP. All right, so it just tell all these things, and I say summary. Give me a summary. Yeah, it is telling 1 and 2. The trunks, it's showing the trunks alone. And I wish to see the port channels also. For that, let me say show interface port channel 1. Yes, so it is showing details about the interface which is connected to the port channel 1. All right. And so it is just giving me a summary of the port channel 1. Right. So let me come to this particular switch. Again, we can configure this switch en config t. So first, initially, we have to tell the VLAN 10 name student, then VLAN 20 name faculty. Right. So we have configured 2 VLANs to it. And then I'm going to tell it as interface range FA 0/5 to 8. All right, 5 to 8. It is switch port mode access, then switch port access VLAN 10, right? And then I say interface range FA 0/9 to 12. All right, so then I say switch port mode access, switch port access VLAN 20. Then interface range FA 0/1 to 2. All right. Then switch port mode trunk. All right. And then I'm going to group it. Right. So I have configured all these configuration, creating a port channel 1. All right. Now we will do a small summary report. We'll take a small summary report here. So show ether channel. Yes, there are 2 ether channels available. So when you do a summary, you could see that the port state has been changed to in channel. Okay, P. Initially, when we just do initial configuration, it was all idle. Okay, because the other side was not configured. It was on a blocking stage. Okay, the other side was on the blocking stage, and then it went to a listening stage and then to a learning stage. But now you could see that they are very active for data transmission. Okay, they are very active for data transmission. So this is how you will configure the ether channel. So for configuring LACP, the one thing that you have to do is channel group 1 mode passive or active. Okay, you will configure it as mode active or passive, because that is what you will do it, right? So So with this, I have completed these chapters of your modules. Okay, so your DHCP4 is what you have already studied. Okay, you can just have a read at it. Right, so Slack and DHCP version 6 is already taught for you. And the next class we will discuss about the FHRP. Okay, chapter 9, 10, and 11 we will be dealing in the next class.